Hello everyone, welcome back to my channel, it's Ara here. In the last video, we compared the performance of ROS1 and ROS2. The final conclusion is that ROS2 is better than ROS1 when the bandwidth is sufficient. But currently, most open source algorithms are still based on ROS1. Therefore, in order to build the communication between ROS1 and ROS2 without modifying the code, we need to use ROS1 bridge, a ROS2 package. According to my test, the current ROS1 bridge package only supports ROS2 Foxy. So in this experiment, we will test ROS1 Nautic and the ROS2 Foxy. We will also compare with the previous results. Let's first demonstrate how to install ROS1, ROS2, and ROS1 bridge package on 1-20 system. Here we will install the pre-compiled binary code and follow the tutorial on the ROS official website. In order to avoid the trouble of copying one command after another, I made some scripts. You can directly run my scripts to install ROS1 and ROS2. After installation, execute the following two commands to install ROS1 bridge. After all installations are completed, we can run the ROS node we wrote before. First, demonstrate using ROS2 to publish and ROS1 to receive. Run the ROS2 node, there is no difference than normal. Then run ROS1 bridge. Since the ROS1 bridge package needs to subscribe to ROS master, we also need to set the IP of ROS1 in bash RC. After setting up, you can run ROS core and the ROS1 bridge. When running ROS1 bridge, we need to source the setup bash files of ROS1 and ROS2 at the same time. Finally, we run ROS1 node. Then we can try to use ROS1 to publish, just modify the publishing and receiving commands respectively. After the demonstration, let's see how different the actual performance is. In order to control variables, we use the same hardware platform, a Netgear R7000, a maximum Wi-Fi transmission bandwidth of 1.9 gigabits per second, and a two laptop equipped with Intel AX211 network adapter. Still transmit RGBD images, that is two 480p 30-frame video streams. Let's look at the results. First, ROS2 Foxy result using ROS1 bridge. We can see that compared to ROS2 rolling, the bandwidth and the latency are slightly reduced, while the frame rate remains almost the same. In the second round of testing, we ran ROS1 bridge on the ROS2 side. That is, we ran ROS1 bridge on the laptop where the image was published. From the results, we can see that compared to the case where ROS1 bridge is not applied, the bandwidth and the frame rate is almost the same, while latency increases slightly. In the third round of testing, we used the laptop that received the image to run ROS1 bridge. We can see that the uncompressed image is almost the same as the result of pure ROS2 Foxy, and the compressed image even has a negative delay. This may result from the bug of inconsistent timing methods between ROS1 and ROS2. But from the perspective of frame rate, delay, and bandwidth performance, they are much better than pure ROS1 Nautic and almost the same as the performance of pure ROS2. In summary, based on the test results, my suggestion is to use pure ROS2 system as much as possible. But if a ROS1 node must exist, it is recommended to run the ROS1 node and ROS1 bridge on the same terminal. As shown here, this structure can minimize the loss caused by ROS1 bridge. Thanks for watching. Please subscribe and leave your comments below. In the next video, I will use C++ and Python to visualize the loss function and the optimization algorithms. See you next time.